Hello dear students, welcome you all. In this lecture, we are going to discuss production of very low temperature, production of very low temperature by using adiabatic demagnetization or we can say by using magneto caloric effect. Clear? That we have discussed in the earlier lecture, right? So here in this lecture we are going to discuss the method to produce a very low temperature. Very low temperature means temperature of the order of 0.001 or 0.002, like that range Kelvin. Clear? Now this temperature is of the order of 0, nearly 0 Kelvin, absolute zero temperature, right? Sorry. So we have seen that for the production of low temperature, we can use Joule-Thomson effect, that is regenerative cooling method, that can be used. But by using that method, we can go up to a temperature of maximum 2 Kelvin, right? We can't proceed further that due to certain limitations. So if we want to go close to the 0 Kelvin, like this temperature, then we have to utilize magnetocaloric effect. That is the process of heating due to magnetization and cooling due to demagnetization of a paramagnetic material. Clear? So here we will see how temperature close to this low temperature is produced by using this adiabatic demagnetization. Adiabatic demagnetization means the demagnetization where there is no exchange of heat between the system and a surrounding. Clear? We have seen it in the earlier lecture. So now I am going to show you the apparatus used by Lenzman dy for the production of this low temperature by utilizing uh, this magnetocaloric effect. So you can see here, this is the schematic diagram of the apparatus used. In actual, the apparatus is complicated, but to understand the entire process in the simple way, we can consider this apparatus or the diagram, right? Here these are the two magnetic poles which are used for producing magnetization in this paramagnetic salt. Clear? Here we take a paramagnetic salt material, like we can take any material which is paramagnetic, right? So here we have taken the material potassium, chromium, alum. Clear? So potassium, chromium, alum is paramagnetic. So we have taken this sample paramagnetic salt, that is potassium, chromium, alum. Chromium, alum. Yeah, this is a paramagnetic material. Clear? We have placed it in this tube that is connected to the vacuum pump. Clear? Now this is B. B is a DVAR vessel. Clear? DVAR vessel, again, I have told you, it is a kind of a thermally insulating vessel. Clear? You can say thermal flask. Clear? That is insulating this from this. Clear? And it contains liquid helium. Clear? Liquid helium means the temperature is around 4.22 Kelvin here. Clear? Here it is liquid nitrogen. Clear? Again, it is contained in a thermally isolated vessel, a DVAR vessel C, and temperature here is around 70 Kelvin, liquid nitrogen, right? So how this very low temperature will be produced, right? So so what we will do, we will first of all switch on the magnetic field. Clear? This magnetic field will be switched on. Clear? Apply H magnetic field. Now what will be the effect of this magnetic field on this paramagnetic material? We have seen it in the earlier lecture. The magnetic dipole moment of this material will tend to align in the direction of a magnetic field. Clear? They will tend to align. H in the direction of a magnetic field. Now, when these material, these atom inside this paramagnetic cell will get magnetized, uh, heat will be produced according to the relation ds is equal to dq upon t. Clear? Order is increased, disorder is reduced, so there will be a production of heat. So then what we will do, initially this vacuum pump is switched off, it is not on. Clear? When this entire process was taking place, this was in off position. It means there is some air inside this tube. So the heat produced here due to the magnetization of this paramagnetic salt will be transferred to this liquid helium. Clear? And then from here it can transfer to here. Although this is thermally insulated, but we know there is possibility 100% thermal insulation is not possible. So it can even travel to here. Right? Now the entire heat that was produced here, that was transferred to here and then to here. Clear? Now what we will do? We will switch on the vacuum pump and we will pull all the air outside. Clear? What amount of air was trapped here, it will be taken outside. So a kind of vacuum will be produced inside this tube. Clear? So what is the purpose of inducing vacuum here? The purpose of inducing vacuum here is that now, clear, there is fully insulation between this sample and this outside liquid helium. Now there is no way of transfer of heat from here to here or from here to here. Now this material is fully thermally insulated. Clear? And at this very moment we will switch off this magnetic field. Now H is equal to 0. Clear? What will happen? All those atoms which have oriented in the direction of magnetic field initially, what they will do? They will try to get randomly oriented. Clear? As we have seen earlier. So when they will align themselves in random orientations, they require energy, they require thermal energy, right? So what they will do? Heat is not supplied from the outside here. So they will utilize their own energy, on internal energy, and the temperature of this sample will decrease. So this is the way this material will get cooled to a very, very low temperature, right? So this is the way how we can produce a very, very low temperature. And as I have told you, that temperature of the order of 0.001 Kelvin was attained with the help of this method, magneto-caloric method, or we can say adiabatic demagnetization of this paramagnetic material, right? So this is the simple description of this entire apparatus for the production of a very low temperature. We have seen how does this happen. All the things were also very clear from the equation that we have derived in the earlier lecture, that there is always production of a low temperature, means T final is always less than a T initial. We have seen it in the earlier lecture. So it is this equation is utilized here, and this is the way how we can generate a very, very low temperature, right? So thank you very much.